Hi, this is Mrs. La Barbara. Today's topic is Newton's first law of motion, part 2, inertia. The objective for today is to know the definition of inertia to understand the relationship between inertia and is defined as the resistance of an object to change its state of motion. So remember, the state of motion means velocity. So inertia is to resist the changing its velocity. If you change your velocity, that means you accelerate. So inertia is to resist acceleration. So Newton's first law many times are called the law of inertia. That means when the forces cancel out, the object's velocity remains constant and its acceleration is zero. So the law of inertia is object resist to change. It will not change. That's what it means. It will not change its velocity. So how do we measure inertia? So inertia can be measured through mass. More mass means more inertia. So more mass, that means it's harder to change. Think about how easy for you to move a little toy car and how much harder for you to push, say, a truck, because a truck has a lot more mass. So it's harder to change a truck's motion than to change a toy car's motion. Let's take a look at an example. Compared to 8 kilograms of feather, 6 kilograms of lead has, what choice is this? Since mass is measured by inertia, so which one would have more inertia? More mass has more inertia. 6 kilograms will have less inertia. So this one should have less inertia or less inertia. Which one has more mass? Well, 8 kilograms obviously has more, so the answer is A. The big misconceptions. The most common misconceptions is one that dates back for ages. It is the idea that sustaining motion requires a continued force. So Newton's law declares loudly that a net force or an unbalanced force causes an acceleration. An unbalanced force only causes an acceleration. An unbalanced force is not required to keep an object in motion. Inertia does. An object in motion already stays in motion. You don't have to do anything. It will keep going. But from your experience, you say, wait a second, if I push a book on the floor, it will start to move, then it will slow down. Why are you saying it will keep moving? Well, I understand your everyday experience, but it slows down because there is an external force. That force, we call it friction force. If there were no friction force, it will keep on going. So the big misconception is to keep an object going, you don't need any force. Are you infected with the misconception? Let's take a look at this example. So two students discussing an object that is being acted upon by two individual forces is shown. It's up and down. These two forces cancels. So during the discussion, analytical suggests to know a formula that the object under discussion could be moving. Now, a formula objects, arguing that object could not have any horizontal motion if there are only vertical forces acting on it. Who do you agree with? Think about it. The one we just talked about. Analytical is correct. Why is that? Because if the object was in motion, suppose it was moving to the right originally. It is moving to the right originally. It will continue to move to the right. It will not need any force in a horizontal direction to continue for it to move to the right. That is a law of inertia. Inertia says an object will do whatever it's doing before. It doesn't need anything else. Well, questions about inertia. Which of the following statements are true of inertia? List all that applies. So first one says inertia is force. No, inertia is a resistance to change. So it's not that. Inertia is a force. No, inertia is not a force. Inertia is force. No, inertia is not force. All objects have inertia. Yes, all objects have mass, so that all of them has inertia. Bigger object, more massive object has more inertia than less massive object. So D is correct. A more massive object has more inertia. That's correct. A fast-moving object has more inertia. No, more inertia or less inertia only depends on one thing. It's mass. So F is wrong. How about the next one? An object would not have any inertia in a gravity-free environment. No, an object will have inertia because the object will have mass. Even gravity-free means force, no gravitational force, no weight, but it still have mass, so it still have inertia. So that's wrong. Inertia is a tendency of all objects to resist the motion. No, it's resist the change in motion. In a gravity-free environment, should there be one, a person with lots of inertia would have the same ability to make turn as a person with small amount of inertia. That's wrong. Gravity-free means there is no weight. There is no gravitational force. You still have mass. More mass, more inertia. More massive person still is hard to move. So the only thing that's correct is D and E. Take a look at the next example. Imagine a place in the cosmos far from all gravitational and frictional influences. Suppose that you visit that place and throw a rock. What's going to happen to that rock? Is that going to gradually stop? Or is it going to continue motion in the same direction at constant speed? Well, according to Newton's first law, an object in motion stays in motion. So the answer is B. How about the next one? A 2-kilogram object moving horizontally with a speed of 4 meters per second. How much net force is required to keep the object moving at this speed in the same direction? Well, an object in motion stays in motion. It doesn't require any net force, so it's 0 net force is required. Last slide. Example, consider Newton's first law of motion. Object in motion stays in motion. Object stays at rest unless acted by an unbalanced force. Determine which of the following statements are true. List all that applies. Newton's first law of motion is applicable to both moving and non-moving objects. That's true. If a football is moving upward and rightward toward the peak of its trajectory, then there are both rightward and upward force acting on it. No, an object in motion stays in motion. Wrong. C, it would take an unbalanced force to keep the object in motion. No, unbalanced force causes acceleration. Unbalanced force causes change in motion. It doesn't keep the object in motion. D, if an object is at rest, then there are no force acting on it. There is no unbalanced force. So it could still be a force. Gravity is always acting on it. Then there is a force supporting it. So the two forces cancel out. So this one is wrong, D. E, it would take an unbalanced force to keep an object in motion at constant velocity. No, again, it will take an unbalanced force to accelerate. But to keep an object in constant velocity, you don't need anything. It's inertia. F, it is natural tendency for all objects to eventually come to rest position. No, that's untrue. It's a natural tendency for an object to stay in motion, continue to do what it's doing. That's called inertia. Why everything comes to a stop eventually? That is because of friction, because of unbalanced force. G, a pendulum bob is set into a usual back and forth periodic motion. This is like grandfather clock. It's keep going. Eventually, you know it comes to stops. It stops because of air resistance. It's not because of inertia. If there is no air resistance, that clock will continually going. That pendulum will continually going. H. If a 3-kilogram rock is thrown at a speed 2 meters per second in a gravity-free environment, then unbalanced force of 6 newtons would be required to keep the rock moving at constant speed. No, it doesn't. An unbalanced force will make it change its speed. To keep at a constant speed, you don't need anything. Last one, it would take an unbalanced force to cause an object to accelerate from rest. That is correct. Unbalanced force causes acceleration. To make it move at constant speed in the same direction, you don't need any force. That's what inertia is. That's it for today. Thanks for watching. See you next time.